3 is x prime. Consider that we model x prime equals rx times x, or a minus x, times x minus b. Yeah? R equals 1, R equals 1, A equals 2, B is 10. Okay. Determine the equilibria and their stability. Okay, so first let's plug these numbers in. So the equation becomes x prime equals 1x times 2 minus x times x minus 10. And if we graph this, we know what this graph is going to look like. So this is x prime and this is x, right? We know that we have the equilibria. So points of equilibria is where there's no change, where the derivative is 0, is where x prime equals 0. So that corresponds to 3 places: x equals 0, x equals 2, and x equals 10. So 0, let's say 2 is here, and 10 is here. Okay, and now we're going to graph. So this is a minus x cubed. So it's going to look something like this. It's going to look something like this. And so to the left of 0, let's put this in green. To the left of 0, it's negative slope, so it's falling towards it. To the right of 0, it's also towards it. So that makes x equals 0 stable equilibrium point. Okay, now for the 2, it's a positive slope to the left of it, so that means it's away from it. And to the right of it, it's also going to come towards it. I mean, away from it, because it's a positive slope. So that means x equals 2, unstable.
It would also be 0 with x equals negative 10 and x equals
negative 10?
Yeah.
Why negative 10?
Oh, no.
Yeah, 10.
Right.
And then for the 10, we have to the left negative slope, so towards it. And to the right, it's also negative slope, so that's towards it. So x equals 10 is stable equilibrium. So that's the idea here. So those are the equilibrium point, and these are their stability categories.